SwayamPrabha. Digital India. Educated India.
Hello and welcome to the lecture 2 of week 10. In week 10 we are studying the control valves and the graphical representation. In this lecture we will be studying the flow control valves and the pressure relief valves, the construction, working details and the applications of these valves. The outline of this lecture is there in front of you. At start, we will look at the importance and need of the pressure relief valve and flow control valve. There are various types of control valves are used in the industry. These are plug valves, butterfly type of valve, ball valve and the balanced valve. We will have a discussion on all these valves. At the end of the lecture, we will see the pressure relief valves, principle of operation and its applications. So let us begin the lecture 2. After studying how to control the direction of fluid flow inside a hydraulic circuit, now let us study how can we have the flow control of the hydraulic fluid inside a hydraulic circuit. Basically, the speed of the actuators which we are using in the hydraulic circuits can be controlled by regulating the fluid flow. So, speed of the actuators can be controlled by regulating the fluid flow. So, to carry out this regulation operation, we need the devices, and the device which is providing that regulation operation is nothing but the flow control valves. So, how can we achieve the fluid flow? We can achieve this by varying the area of the passage. The fluid flow can be varied or can be controlled by varying the area through which the fluid is passing. So for this purpose, there are a variety of mechanisms are available that we will be seeing in the next slides. When we are using such devices, there is an inherent problem or there is an inherent characteristics of this system is that they are generating the pressure drop. So when we are carrying out the change in the direction of fluid flow or when we are controlling the flow of the fluid, there is a pressure drop. And this pressure drop is to be considered during the selection of a proper flow control valve. In typical hydraulic circuits, there is a pressure fluctuation at the load. At the application, we are having the fluctuation in the load. So the load is varying. Sometimes we are having higher load, sometimes the load is less. However, the inlet pressure is constant. The pump is giving the fluid at a constant pressure, but the outlet pressure may be different. The inlet pressure is constant, whereas the outlet pressure is varying. So to take care of this fluctuation in the load, either we can have the pressure compensated pumps. So we can compensate the pressure at the pump level itself. We can have the pressure compensated pumps, or we can have pressure compensated flow control valve. Pressure compensated flow control valve. These control valves may have the spool, and by changing the position of the spool we can change the area of the passage. We can change the area of the passage, and accordingly the required flow can be maintained during the flow of fluid through the device, that is a control valve. Well, in addition to the pressure compensation, the hydraulic systems are having the temperature problem as well. As we have seen that a lot of moving components are there, the friction of the moving components is generating the heat energy. As the temperature is increasing, that is affecting the viscosity of the hydraulic fluid. The viscosity will be reduced. So as the fluid's viscosity is reduced, we have to change the flow rate. We cannot apply the same pressure, we cannot have the same flow rate of the hydraulic fluid. A very basic and simple example of the flow control valve is our household tap. So on your screen you can see a schematic of a household tap. So it is having the pipe through which the fluid is passing, and this pipe is fitted with a flow control valve. The flow control valve is having a flow adjustment screw, and that flow adjustment screw is having a ball. By rotating the flow adjustment screw, we can vary the orifice area. If the area is reduced, then the flow would be restricted. The control will be there on the flow. The flow will be minimized. As we are increasing the area of the orifice by rotating the flow adjustment screw, more amount of fluid will be passed through the passage. So by varying the area of the valve, we can certainly have the passage of the fluid as per our requirement. There are various types of flow control valves are used in the industry, and some of the valves are the plug or the glow valve, butterfly valve, ball valve, and the balanced valve. So let us look at the construction and working of these valves. The plug or the glow valve. The plug valve is also called as the glow valve. So it is having a plug. Plug is nothing but a tapered cylindrical component. As you can see here, this tapered component or part is placed in between the passage of the fluid flow. The position of the plug inside the fluid flow is controlled by a flow adjustment screw. As we rotate the flow adjustment screw, there is movement of the plug inside the passage. The accuracy of fluid flow is dependent upon the accurate machining of the taper angle of the plug. The adjustment of the plug is altering the orifice size between the plug and the valve seat. The typical example of the plug valve is the stopcock, which we used in our glassware, that is laboratory glassware. So in general, the body of these plug valves is made up of glass or Teflon, and the plug is made up of plastic or the glass. The next type of valve is the butterfly valve. In the construction of the butterfly valve, we are using a disc which can rotate inside the pipe. You can see the construction of a butterfly valve. So this is the body of the butterfly valve, and inside that we are having the disc. So as we change the orientation of the disc, we can easily control the orifice. We can easily control the area of passage of fluid flow inside the pipe. So if you rotate this either by using the electric motor or by using the manual operation, you can rotate this disc. So as you are rotating the disc, you can easily change the passage. So typical arrangement also can be seen on your screen. So this is the top view of the butterfly valve. The disc can be rotated about its vertical axis. The angle of the disc determines the restriction. So in general, the resilient type butterfly valve uses the flexibility of rubber and has the lowest pressure rating. The butterfly valves can be made of any size, and they are widely used to flow the fluids as well as the gases. Can be used to transport or to control the liquid as well as gases. One important characteristic of butterfly valve is that there is a constant pressure drop. Although we will be holding the disc in a parallel direction to the walls of the pipe, then also there would be a pressure drop. There is a constant pressure drop in case of the butterfly valve. But in this case, the pressure drop would be minimal. The disc of the butterfly valve are generally made up of plastic or steel. So in general, stainless steel is used, and if you add the nickel, then it offers us a high corrosion resistance. The next type of valve is the ball valve. It's very widely used in the industry. So here we are using a ball which is rotated inside a machined seat. The typical construction of the ball valve can be seen on your screen. So it is having the body. This is the body of the ball valve. There is a seat, and that seat is housing the ball. The ball is the floating ball. Ball is floating, and the ball is having the passage as well. It is having a through hole through which the fluid is passing. The ball valve is operated by a lever, and the lever is having a stem. So as the lever is rotated, the ball is also getting rotated, and then we can easily have the passage of fluid through the perforated ball. So if the passage is in line with the passage of the body, then the fluid will be passed in this way. Otherwise, if this portion comes here in this way, it is shutting off the fluid flow, it is stopping the fluid flow. The ball valves are widely used for the shut off conditions, shut off applications as well. These kind of valves are used for high pressure applications. Around 1000 bar pressure can be sustained by these ball valves, and they can work at a very high temperature as well, say around 250 degrees Celsius. So on your screen you can see some of the steel balls which are machined. These are the steel balls which are machined. This is the circular passage which is machined inside the spherical balls, and these spherical balls are having the protrusion at the top and at the bottom, which is used to get hold inside the lever and the stem arrangement. The next type of wall is the balanced wall. The balanced wall is having two plugs. So if there is only one plug and one stem arrangement, there may be chances of having the excessive thrust on the stem body, and due to that excessive thrust there may be more wear and tear, more damage to the stem of the valve. To avoid that, we are using two plugs. So here we are having plug number 1 and the plug number 2. Both these plugs are precisely machined, and a spool is housing plug 1 and plug 2. The spool with plug 1 and plug 2 is rested on seat 1 and seat 2. The corresponding seats are provided for plug 1 and plug 2. The entire arrangement is kept inside the passage of the fluid. The pressurized fluid is coming, and then it is passing through the passage provided by the plug 1 and plug 2. So if we provide the upward moment to the spool, there would be a gap between the plug 2 and plug 1, and the pressurized fluid will pass through here. So as the pressurized fluid is passing, there is application of the pressure on the stem on this side, but the pressurized fluid which is coming in this area, this will also apply pressure on the stem in the opposite direction. So that little dynamic reaction on the actuator shaft in the opposite direction is balancing the pressure applied by the fluid in the forward direction. So due to this, we can balance the application of pressure on the stem, and we can reduce the damage to the valve. However, this type of balanced valves are having the problem of leakage, because the tolerances which are provided on the plug 1 and plug 2, if there are inaccuracies, if there are imperfections in the machining of plug 1 and plug 2, then we may have the leakages from plug 1 or plug 2. So therefore, the machining of the taper of plug 1 and plug 2 and the tolerances are to be tightly maintained during the machining process. During the hydraulic circuit operations, we need to control the direction of the movement of the fluid, as well as we need to control the flow rate of the fluid. In addition to these two important factors, we have to control the pressure inside the system. If the pressure of the system is excessively high, then that will damage the entire system. There may be catastrophic failure of the hydraulic system, there may be bursting of the system, and to avoid such failures of the system, we should employ the pressure relief valves. The pressure relief valves are basically used to protect the hydraulic components from the excessive pressure. These are very essential for the safe operation of the hydraulic system. The primary function of this relief valve is to limit the system pressure within a specified range. We are also using the pressure relief valve during the cooking operation as well. In a similar fashion, there are a lot of pressure control valves are used, pressure relief valves are used in the industry, in hydraulic industry, and these are the direct type of the relief valve, unloading type of the valve, and the pressure reducing valve. There are also two types of valves being used. These are the sequence valves and the counterbalance valve. So at the preliminary discussion, we will be studying about the direct type of relief valve, unloading valve, and the pressure reducing valve. The direct type of relief valve is having two ports. The first port is the pump port, at which we are applying the pressurized fluid, and the second port is the tank port. These type of relief valves are put inside the hydraulic circuit when the pressurized fluid which is coming inside the valve, if that pressurized fluid is having pressure more than the specified pressure or the predetermined pressure, then the valve will get actuated, the valve will get operated, and it will drain, it will bypass the excessive pressurized fluid to the tank. So to have this arrangement, we are having the body of the valve. The body of the valve is having a passage, or it is also called as the control chamber. So inside the control chamber, we are using a poppet. So the poppet is the spring loaded poppet, and we can even adjust the spring loading or the spring constant by using a screw. So when the applied pressure is more than the set pressure by the spring, the poppet will be moved in upward direction, and the excessive pressurized fluid will pass through the passage provided here, and it will bypass to the tank. So during the operation, there may be leakage of the fluid inside the upper portion of the body of the pressure relief valve. So to drain that leaked hydraulic fluid inside the body, that also can be drained by using a small passage provided here. This will protect the failure of the valve due to the leakage problem. The second type of pressure control valve is the unloading valve. The unloading valve operation is very much similar to the DCV that we have seen in our previous lecture. In one of the direct control valve, we have seen that a pilot pressure can be utilized to, to use or to convert the direction control valve as the unloading valve. The unloading valve is having a control chamber. So this is the control chamber of the unloading valve. It is having an adjustable spring. So this is the adjustable spring. The adjustable spring is pushing the spool down. So this is the spool. The spring is pushing it in a downward direction. The unloading valve is having two ports, that is a pump port and the tank port. And we are also having a remote pilot pressure signal port. So in normal condition, in general, this valve is the closed valve. This is allowing the system that to run at a constant pressure at minimum load application. But when the pressure is increased, when the pressure is above the critical value, then the valve will get operated. If you consider if the pressure is more, then the valve will get pushed in upward direction and the excessive pressure of the hydraulic fluid will be released by bypassing the fluid to the tank itself. So this is one scenario. In certain cases, if we are having the signal arrangements, if we are having the sensors and the microprocessor arrangement, and this sensor and the microprocessor arrangement is continuously monitoring the fluid pressure inside the system. Based upon the signals received by the sensors and the decision taken by the microprocessor, we can actuate a pressure signal to the pilot arrangement. So as we have seen that pilot arrangement is nothing but an externally applied hydraulic fluid. The separate system is there and that separate system is applying fluid, pressurized fluid at this location. So through this passage, by using the solenoid valves which are operated by the microprocessor, we are pushing the spool in upward direction. As we push the spool in the upward direction, the tank port will get open to the pump port and the pressure which is built up at the pump, the excessive pressure which is built up at the pump, that will be released by bypassing the excessive pressurized fluid through the tank. So in this way we can have the continuous monitoring of the fluid flow inside the system, and we can have an automated fluid flow monitoring system, automated fluid flow control system by using the sensors and the microprocessor arrangement. So various types of fluid flow sensors that we have seen in the previous weeks, we have also seen the technology related to the microprocessor. The next pressure relief valve is the pressure reducing valve. And the purpose of this valve is to limit the outlet pressure inside the system. By controlling the outlet pressure, we can safeguard the hydraulic system. The typical pressure reducing valve is on your screen. It has the body. The body is having a chamber. The chamber is housing the spool. The spool is being maintained by the spring. The spool is operated by the spring, and the spring is being controlled by a pressure adjustment screw. The stiffness or the pressure on the spring is controlled by the pressure adjustment screw. The valve is having two ports, that is a pump port and the outlet port. So when the outlet pressure is more due to certain reason, for example, these kind of valves we are using for the holding purpose, the pressurized fluid is applied to hold or to clamp a device. The excessive pressure which is being applied inside the system may lead to the failure of the work part, or it may lead to failure of the system itself. So when the pressure at the outlet is more than that back pressure which is created is applied at the bottom side of the spool, and that back pressure will push the spool in upward direction against the spring. And as the spool is moved in an upward direction, the pressure at the outlet port will get relieved. The pressure at the output port will get reduced, and in this way we can save the damage. We can protect the wall by getting damaged. So whatever the fluid which is leaked in the gap between the spool and the wall body or the bore of the wall, that will be drained through small port that we call the drain port. Thus we can summarize that pressure reducing valve is allowing free flow of the pressurized fluid from the pump to the controlled pressure outlet until a signal from the outlet port which is asking to throttle the passage through the valve. The meaning is that there is continuous flow is allowed, but in case there is increase in the pressure at the outlet, we need a control signal. We need a signal. That signal is making the throttling of the fluid, that is reducing the pressure of the fluid inside the system. So that is possible by using a simple control signal line which is provided as you can see on your screen. In this way, these all variety of valves are helping us to maintain the direction of the fluid inside the system, the flow rate as per the desired value, and they are safeguarding the entire system. Well, let me summarize the lecture 2 of week 10. In this week, we have seen two important control valves, and these are flow control valves and pressure relief valves. We have seen the constructional details, principle of operation and application of variety of valves. These were plug or glow valve, butterfly valve, ball valve and balanced valve. Well, in the next lecture, that is lecture 3 of week 10, we will see how to graphically represent various elements of a typical hydraulic system. Hydraulic system elements are very complex, as we have seen, and when we club them together, when we integrate them together, the design becomes very complex. So to synthesize it in a proper way, to understand the meaning of the circuit or the arrangement easily, we have to represent them graphically. So that we will be studying in the third lecture of the week 10. We will study the representation of various elements such as pumps, valves and actuators. So till then, goodbye. Thank you.